Okay, now what we're going to take a look at is vector operations. So again, it's kind of the algebraic way of adding two vectors, scaling vectors, and just kind of a combination of those two operations. We have previously looked at the diagrams of how you go tail to tip to draw the resultant or the sum of two vectors. We've also looked at how we can scale out vectors by just multiplying their lengths by a certain scale factor. When we're working with these position vectors, we can also do all of that stuff algebraically. So here are the four examples we're going to look at. We're going to find u plus v, which is actually going to represent the resultant then, or the sum of vectors u and vectors v. We're going to scale vector v by a scalar of 5, which again should make that vector 5 times as long. C here, we're going to find the opposite of vector u. Remember, negative u just means the opposite. It's the exact same length, just 180 degrees in the opposite direction. And then D, we got kind of a combination of finding, a scalar of u, a scalar of v, and then also finding their sum or their resultant. So let's take a look at the first one. These vector operations are actually very nice. It's a heck of a lot nicer to do this than when we have these things written in position vectors than trying to draw the sketches and tail the tip. This is just going to be a little more accurate. So here's how we find the resultant then, or the sum of two vectors. You're just going to take each of your vectors. Here's vector u. We're going to add that to vector v. And all we really need to do here is go ahead and add like components. So we'll add the two horizontal components, 3 and 1. That's going to give us 4. And we'll add the two vertical components, the two y-coordinates, which is -5 plus -9. So -5 plus -9 is going to give us -14. So again, if we looked at a diagram or put these on the coordinate plane, you would see that 3 -5 plus 1 -9 would be the same resultant, or if we moved one tail to tip, as 4 -14. Okay. Take a look at B here, scalar products. Really, whenever you see these scalars, just think distributive property. So 5 times V is going to be 1 -9. And again, we'll literally just distribute the 5, multiply each component here by a factor of 5, and that'll give us a vector that is then 5 times as long, but keep in mind that should be pointed in the exact same direction. So 5 negative 5 times 9 is 45. Okay. And there is the position vector that represents 5 times v. Again, it's still in the same quadrant, still in this exact same direction, just 5 times as long. Opposite vectors. Okay. So the opposite of u, basically what we're going to do is we're going to distribute a negative, or distribute the -1 through vector u. Okay. Which again should just face the vector in the opposite direction. So we'll go ahead and distribute a negative throughout this vector. It's going to switch the sign of each component. So the opposite of 3 -5 is going to be -3 comma +5. And again, it does kind of make sense if you look at that one graphically. These numbers didn't get too big, so I'll go ahead and show this one here. But the first vector we had here, vector u, is 3 -5. So it's 1, 2, 3, 1, 2, 3, 4, 5. So here's 3 -5. And then what we just found is opposite of vector u, which would be -3, 1, 2, 3, +5. So we would go ahead and sketch that vector in. And we can see then that there is going to be 180 degrees apart. Same length, same magnitude, just pointing in the opposite direction. All right. Now here's a combination of operations here. We have scalars on both vectors, and we're trying to find their sum. So we do need to follow the order of operations still. That's still the same. So we're going to do the multiplying, or the scaling first. And then we will find the sum. Oops, forgot the scalar of 5 there, so we'll put that in. 5 times vector v, which is 1 comma -9. All right, so following the order of operations again, we'll distribute first. So it's going to become 3 times vector u is going to be 9, -15. And we can also do the second scaling here. 5 times 1 is 5, -45. We found that one up above. And then finally, finally, we can do our addition, which again, reminder from A here is just to add like components. 9 plus 5 is 14. Negative 15 plus negative 45, adding the negatives up there will actually give us negative 60. And that is then the final answer, the vector that would represent 3u plus 5v. So, all right. Good luck on the guided practice.